It is Thursday, February 4th, and we are going to share. First, we're going over the, dismiss that camera. Okay, so your homework last night was 5 and 6. So if you're given the midpoint, then basically what you do is you work, oh, it's not sharing, is it? Let me go back to the share tray. Thank you. Annika, I love that you always answer my question. You always answer me when I ask, you know, always, you and Jack and Xavier, and not that everybody else does, but I always see you. Okay, here we go. So when I just drew this little picture so I knew what was what. So M is the midpoint, J was on this end, you had to find K. So for each one, I set the midpoint equal to those, and I did a little bit of work. I got X sub 2 equals 11, Y sub 2 equals 5, so your final point is 5. Remember, you always want to circle or box your answer clearly so that we know what we're looking at. It's just sort of going backwards. If you know what the middle is, you can figure out what this is. So then the algebra review for these trinomials, this is what you get after you multiply two binomials out. Okay, and so if you don't remember, because we didn't go over them too much, the first term, the a squared, that's the first two multiplied. That's a times a. The last one is 2 times 9. Now you don't know if it's 2 times 9, 1 times 18, or 3 times 6. That's why I have the factors here. What you have to figure out is which pair of factors will give you 11 when you combine them. So you also have to think about negative numbers too. But in this case, they were positive, and so 2 and 9 add up to positive 11, so it's plus 2 and plus 9. So this is how they worked out. Okay, this was beginning algebra. This was a little later. Once we started out having 2s and 3s and 4s in front, this is how it multiplied out. And I know this one can't be factored in particular because I wrote out all of the factors of 24, and none of them in any combination of positive or negative. I mean, it's supposed to be positive 24, but none of these will give me a negative 4 when I combine them. So that's how I know it can't be factored, because I checked all the possibilities. Okay, any questions right now on this? I also have the proofs done, and I will go over them at another time, okay, because I want to review CPC-TC and I want to get straight to our notes today. So as far as our notes go today, as I mentioned, this chapter is all about quadrilaterals. So quadrilaterals are anything with 4 sides. Most of them that we think of are squares, rectangles, and rhombuses. That's like a squished square. Okay. And this is a Venn diagram about how they work. And then you have other things called parallelograms, which fit in this. So all squares, rectangles, and rhombuses are parallelograms, but not all parallelograms are squares, rhombuses, or rectangles. Then we have these other things called trapezoids and kites. They're quadrilaterals, but they don't fit as a parallelogram because they don't fit the definition. So this is a handy dandy little chart that I handed for you. It's either already in your notebook or it's going to be in your notebook. Okay. And then what we're going to do today is we're going to start those notes that I told you are in the class notebook. Okay. We may or may not get through all of them, but I have a 20-minute video that I put on the agenda yesterday, remember, and it's got some of it in here. So I'll skip everything that's in the video and hopefully we'll be able to get to it. Anything we don't get to today, we'll just do tomorrow. That's fine. I'm going to go ahead and switch just to the daily agenda so we can see. Remember, tomorrow we'll be going over the chapter. So it didn't switch with me. Okay, here we go. So tomorrow we're going to be going over. Oh, it's not switching with me. It's lagging. Okay, let's try it again. Reshare. That's why I have another computer. There we go. All right, just as a reminder, here's your chapter 6 vocabulary if you want to review that. And here is chapter 7 if you want to start there. So here's our daily agenda for Thursday, February 4th. So we went over that, right? We just did that review. Now we're going to start these. The BIM assignment has popped up. It's not due till Tuesday, so you have today, tomorrow, and Monday. Don't worry about, but you could start it today because it's a lot of problems. It is. And they're short, quick problems. Remember, the class retake will be on Monday. So then tomorrow we're going to go over the chapter 6 quiz. If you don't want to retake it, you're going to use that as work time. Any of the notes we don't finish, we'll do that. By the way, yesterday's midpoint and distance review, it was about 8 minutes. If you want to see it, there is a video. And then last, I want to just show you on the 3rd, this video right here, it's 18 minutes. But when I say the video for yesterday, that's where it is. Okay, so some of our notes are in this video. There we go. Any questions right now? I'm going to look at you all for a second. Any questions? Okay. So I'm going to start on the notes. You know where they are. They're in the class notebook. I have them under my camera. So if your internet's lagging, when I'm on the camera, you don't necessarily need to have it on. And we're going to start right now. If you need to get up and go grab your printout, please go ahead and do that. Don't at all feel like you need to stay here without that. Okay. Yep. Getting myself together. Thank you for starting. Okay. So we're going to talk about the angles of polygons. This is any polygons. First part is interior angles. Second part is exterior angles. First part is much bigger. So here's what we're going to do. There's some formulas you have to learn. So this is my name, right? Our objective is that I will be able to derive and use formulas for the measures of interior angles, of convex polygons. I'm going to get a different pen. This one is, see, it's supposed to be sharp, but it's way too fat. So I think I'm going to try to use my other. This one I think is a little better. All right. Remember, put your hand up or unmute yourself if you have a question. Otherwise, it's a fill in the blank, right? A polygon. Polygon is a closed plane figure formed by 3 or more line segments called sides. There you go. Classifying polygons. There's 2 different kinds. So vocabulary. There is convex and there is concave. I don't know if you've heard the word, but there is concavity. It talks about how something's hollowed out. Concavity. Okay. Maybe in ceramics you'd hear that. Now we have a string test for it, sort of like the function test, you know, with a straight line. But if you imagine a string wrapped around the polygon, if there's a gap between the string and a polygon, then it's concave. It goes inward. If there's not a gap, then it's convex. Okay, so convex is like everything from the inside is sort of like pushing out. That's the way I think of it, is outward. So if we look at these examples here, imagine placing a string around each of the polygons. Which ones are convex and which ones are concave? Which ones aren't even polygons? Okay, so you should be able to look at these and say, all right, which ones are convex, which ones are concave? If you had a string around it, would there be any gap here? No. So this is convex. If I put a string around it, gap, 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 gap. That means this is concave. It goes in. This one doesn't even have any sides, so this isn't even a polygon. Normally I would be calling on you, but because I'm recording and for the sake of brevity, because these notes are long, I apologize. These, everything's all pushed out. If you had a string, you could wrap it around without gaps. So that's convex. Again, convex. But if I look here, if you had a string around here, your string would come like this, right? So that gap makes that concave. Rhombus, convex. This one doesn't even have a bunch of sides, so that's not. And again, that's a gap. So this is going to be concave. There's a cave in it. And again, this is not a side. So this is a knot. This is not a polygon. Any questions? Okay. Now a bunch of these you actually already know. We have specific names for polygons that we use very often. Yesterday I told you that anything could be called an n-gon. Okay, but specifically you know what some of these are called. So again, since they're notes, if it has 3 sides, it's called a triangle. If it has 4 sides, it's called a quadrilateral. Quad is 4 and lateral is sides. 5 sides, pentagon. 6 sides, hexagon. 7 sides, heptagon. 8 sides, octagon. 9 sides. This one always nonagon. 10 sides, decagon, just like a decade of 10 years. 11. Oh, I don't know what an 11 side is. I don't have that. I don't know what an 11 is. You could call it an 11 gon. Whoops. And 12. 12 is dodeca. Dodecahedron. I know what 20 is. 20 is icosahedron. Let's add that. Icosahedron, because that's like a soccer ball or football. Okay, and then an N obviously is an n-gon. So like 11 would be an n-gon. I don't know if there is an 11. Oops. All right. So again, any questions?
Miss Payne.
Yes.
An 11 by its shape is a hendecagon.
It's a what?
Hendecagon.
Just H-E-N? Hen.
Hendecagon.
Thank you. In my notes, I went straight from 10 to 12. Thank you so much for looking that up. Okay, now my notes are complete. You guys are the best. All right, now this is sort of an exploration because it's such a meaty topic. There are lots of things, and what I really want you to be able to do is I want you to be able to remember this formula without just memorizing it. And so that's why these notes are going to take longer. I really want you to understand and go with this. Okay. Now it's gonna, some of you it's gonna click right away, and some of you maybe the second time you see it, some of you maybe the third, but eventually your brain's gonna go, oh, I get it. This makes sense. I mean, I'm a visual learner, so for me it made sense when I saw the picture. All right, so first of all, let's look at some vocabulary. All right, the first word is consecutive. Okay, consecutive means one right after the other. So 1, 2, 3, 4, 5 are consecutive numbers. They're right next to each other. Okay, and vertices is the plural of vertex. Okay, in a polygon, two vertices that are endpoints of the same side. This is the important part. Endpoints of the same side are called consecutive vertices. Okay. So, for instance, a consecutive vertex would be here and here because they share this side. Look at that. Okay. They share this side right here. Same side. So, like this and this are not consecutive because they're not on the same side. So you can't do that. However, what we're going to define as a diagonal is between two non-consecutive vertices. Okay, so a diagonal is like this, like here. Okay, so this is a diagonal, or for instance, this is a diagonal. Okay, those are diagonals. Together, consecutive, non-consecutive diagonals. Now, it's time to complete the exploration. Now, we don't have groups, so, oh, this is Mrs. Payne. So, of course, I'm just, we're not going to do this part, but we are going to fill it out. Because what you would notice is that, see how this is now broken up into three triangles? Here's a triangle, here's a triangle, and here's a triangle. So what you would notice through this, exploration that we're not doing, is that if a polygon has n sides, then it has n minus 2 triangles. This has 5 sides, so it has 3 triangles. Because if you think about it, this side here and this side here is taken out to make those. And then you have 1, 2, 3, right? 3 sides, which is 2 less. It makes 3 triangles. So if you want to know, like, how many degrees are on the inside of these angles, you know how much 1 is, right? 1 is 180. So to find the total degrees in a polygon, all you have to do is multiply the number of triangles in the polygon by 180 degrees. So in this case, it's 3 times 180. That leads us to our theorem. So every polygon can be cut up into triangles. That's what we're saying. Okay, every convex polygon can be cut up into triangles. So here's the formula. Okay, in this convex n-gon or hexagon, there's 6 sides. So if I cut it up 1, 2, 3, cut it up into. Okay, there's 4 triangles. So the formula for the sum of the measures of convex is 180 degrees times n minus 2. So in this case, it would be 4 times 180, which is 720 degrees total for a hexagon. So that is the formula that's why there's so many problems, because you just have to do this a bunch of times and figure it out. Okay, any questions yet? All right. I know I'm taking up a lot of your time synchronously today, which means you're going to get asynchronous time tomorrow, etc. All right, find the sum of the measures of the interior angles. So the first thing you have to do is count the number of sides. 1, 2, 3, 4, 5, 6, 7, 8. So here, n equals 8, which means the sum of the measures is 180 times 6, because that's 8 minus 2. And that's, wait, 600 plus 480. So that's going to be 1,080 degrees. Okay. And again, if you were just going to cut it up, you go from one vertex, if you want to see it. So from one vertex to all of the other ones, that's non-consecutive. Just to check, let's just see. And there's my last triangle. Yep. 1, 2, 3, 4, 5, 6. Hopefully you can see it now. Okay, second kind of question. If I tell you what the answer is, I tell you the sum of the measures, let's say it's 900, then tell me how many sides there are. Okay, so in other words, I'm going to give you this number, and you have to tell me that number. So it's 900 equals 180 times n minus 2. That's our formula from right here. So I'm going to divide both sides by 180. Boom, boom. I'm going to add 2 to both sides. Over here, I get n equals 7. Therefore, it is a heptagon. Ta-da! Have you guys ever done work like this before? Just looking for a couple of you. So I think this may be the first time you've seen it. That's why we're going to do a lot of problems on this, and I may even give you even more time, but this first section is interior. And we've just done interior, we'll do exterior too. All right, and then last, find the value of x. So this is where we look, this is 1, 2, 3, 4 sides. So 4 sides means the total is going to be 180 times 2. So it's going to have a total interior of 360. That means that if I add this, 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 and this, I should get 360. So I can write a little formula. 108 plus 121 plus 59 plus x equals 360. Now, you can do this with a calculator, or you can do it on your scratch paper, but you can trust me, of course, and tell you that I already worked it out, and I got 72 degrees. So with this one little formula right here, there's 3 different ways we can do this. Yes, it is. Who is Chloe?
Yeah, can you explain where you got 2 again?
Oh, sure. So 1 side, 2 sides, 3 sides, 4 sides. And this is a convex polygon. So my formula is 180 times 4 minus 2. Or the other way you could think of it is this. How many triangles does this make? So this triangle is 180 and this triangle is 180. So I know that that's going to be the total, 360. I guess I did skip that a little bit. So I counted 4 sides. I did 4 minus 2. I got 2 times 180 is the total. And then I add it up and get 72. Okay?
Thank you.
Yeah, thank you, Chloe, for asking that. I do sometimes go a little faster because, I know this down pat, but sometimes I have to remember. Some of you have never seen this before, so I got to remember that. All right. Types of polygons. So I'm going to move on from those types of problems. You'll have plenty of practice. There are 3 more vocabulary words. If we say something is equilateral, remember, that means all the sides are the same. Equilateral. They're all congruent. If we say it's equiangular, right, then it's all angles are congruent. However, if we use the word regular, not as in normal, but as in everything. Everything is the same. Any regular polygon has both sides and angles. So all sides and angles are congruent. That means regular. If you see that word regular, bam. Okay, so again, that's just vocabulary you will have to learn. And sometimes it's just as easy as remembering that's what regular means. Okay, this is pretty much all of the interior angles. Okay, I'm going to move on to the next page. Again, today is notes. Now, let's just say, for instance, what if I have the measure of an angle in a regular polygon? So let's say I have a regular polygon, and I just want to know, like, one angle. See how you could actually figure out how many sides there are? So there's another formula if it's regular. And this formula will give you one angle in the polygon. So first we get the total, 180 degrees times n minus 2. Right, that's how we would get the total. But then let's say I just want one of these. And there's 1, 2, 3, 4, 5, 6. Wouldn't I just divide by 6? If I get the total and I want just one of them and they're all the same, I would divide by 6, right? I can see you all shaking your head. Well, so the formula for any regular polygon, just divide it by the number of sides, or hence the number of angles. So this is only if it's regular, but it makes sense. This gives you your total, right? And this is your number of sides, or your number of angles. So again, highlight that. You're going to learn it. You're going to practice it. There's all kinds of... now this is in the video, okay, that I asked you to watch yesterday, which it's fine if you didn't. I'm going to ask you to go get that example from the video. But this one here, if I want to find the measure of one interior angle of a regular 15 gon, okay, all you got to do is plug it into the formula where n is 15. Okay, so it's going to be 180 times 15 minus 2 over 15. That will give us 1. Okay, so 180 times 13 is 2340. And when you divide it by 15, you get 156 degrees. So if I had something that had, there was 15 sides and all the same angle, this is the total number of angles, and then this gives me just one angle. That's it. That's all there is to it. Again, I'm pausing to ask for questions. Nobody has any questions. Okay. Good. We still have another 10 minutes. I think I'm going to take all of the time and keep going because we're pretty much done with interior. Now, exterior angles, you're going to find much easier. Much, much, much easier. Does anybody know why exterior angles are going to be much easier? I'll give you a big hint. If you stand in one place and you turn all the way around, how far have you gone?
360 degrees.
Thank you, Jack. 360. And guess what? Every time you turn yourself all the way around, it's always going to be 360. Always, always. right? I mean, you're never going to go like more than that. So the sum of the measures of exterior, which means one angle at each vertex, as you can see the picture, is 360. And it's always 360. It's never, ever, ever not 360. So that's why I was like, okay, interior angles are kind of hard, but exterior is always 360. Bam. The hard part will be keeping track because there'll be so many numbers, you'll be like, wait, what's what? Just remember, when you turn all the way around in a circle, you have gone 360 degrees. So like say in this picture, it'd be the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 plus the measure of angle 4 plus the measure of angle 5, bam. And so it would be 360 if you were going to write an equation. Okay, that's it. Now, number 6 here, find the value of x. There's 4 angles, 1, 2, 3, 4, and you know that they add up to 360. So hopefully you can see what you need to do. You're going to add them all together. So 2x plus x plus 67 plus 89, and they're all equal to 360. So now your regular algebra is going to kick in. Your like terms are going to be here. You're going to subtract that from both sides, which I don't even know what that is. 67 plus 80. I don't have my calculator with me.
156.
Thank you. You guys are the best. And so you end up getting 156? Is it?
Yeah.
Are you sure? Oh, this is 156. So when you subtract 156, what do you get? 204? So subtract 156 and divide by 3 for me. Do you get 68? I think it's 68. Anyone? Okay. Pretty sure that's it. Again, we're moving on because I'm trying to get this all the way done. This would be great if we could finish. Now, a convex hexagon has exterior angles with all these. So hexagon tells you how many sides?
6 sides.
Right, 6. And they give you 5 of them. So you write 34 plus 49 plus 58 plus 67 plus 75 equals 360. Oh, plus x. Plus 6. 1, 2, 3, 4, 5, 6. Yeah, I got all 6. You add them all together, you subtract, you get x equals 77. So it's pretty simple as far as those problems go. Okay. So I'm pretty sure that that is the end of those notes. Okay. So how could you find the measure of one exterior angle? In a regular polygon, remember it has to be regular. It's almost the same as it was with the angles, right? If we know that it always, always, always has to add up to 360, wouldn't you just divide by the number of sides? Okay, so exterior angles equals 360 over n. That's it. Questions so far? No, good. Okay. This trampoline question is also in the video from yesterday. And I do believe that that is the end of the notes. Woo! Just barely finished. Okay. So we were able to do both interior and exterior. Now I know this was a lot of talking at you. And then, like I said, there's going to be a lot of small problems, and they're going to be a lot like this, you know, like these. And so for today, with those 3 absentees, hopefully the recording will come in handy for them. And so, and I'll post it for you if you want to see it again, but I'm going to stop for now. Stop.